Hi there. In this video I want to walk you through how to generate a Eagle PCB board and subsequent Gerber files beginning with a Eagle schematic. So here is the schematic that I'm going to be using as an example. It is a laser dot gun, and it essentially runs off two CR2032 batteries. There's a push button switch which, when energized, will begin charging this capacitor here through this resistor. As long as that capacitor is below a certain voltage level, this will be read as a logic low, which comes with the inverter version. Here will be a logic high. When this is high, this voltage, which is connected to the gate of this transistor, which when on turns on the laser diode, will remain high as pulled up by this 10 kilo ohm resistor. When this capacitor voltage exceeds a threshold voltage here, the output will go low, and through diode D2, the gate of the transistor will be pulled low, and the laser diode will thereafter be turned off. During the time that this capacitor is still having a voltage that is below the threshold of this gate, the second inverter gate is set up using this feedback capacitance or resistance in capacitor C3 to act as an oscillator. And this frequency of the oscillator is adjusted by this variable resistor or potentiometer R5. And every time this voltage at the output of this inverter goes low, it will pull the gate of the transistor low, turning off the laser diode. When this output goes high, the gate of the transistor will go high through R2 and turn on the laser diode. So in effect, what happens is when you pull the trigger over here, the laser diode will pulse at a frequency determined by R5 for a duration of time, which is somewhere around, I don't know, hundreds of milliseconds to a second or so, until this RC here times out, or the capacitor charges enough to pull the gate of the MOSFET low. So that's the basic circuit, and there'll be a tuned receiver that will react and respond to that particular frequency that you're going to send it. You can throw this switch here from the laser gun to the laser pointer side, and when you do that, basically the laser diode will turn on whenever there's 5 volts applied here, because the 10K will pull the gate up, and the 5 volts will be applied whenever this button is pushed. So you can use the gun as a laser pointer or as a laser gun. Okay, so after you've done the circuit board layout, you're ready to create a board. Now, for those of you who are watching this in conjunction with the end of the semester project in ENP231, you'll notice that my schematic here has a few things that are different from the schematic that I gave you. Mainly, I have added 2 batteries here, and these are actually battery holders, the surface mount battery holders, because I wanted to provide an option to use a surface mount battery holder rather than an external battery housing that has leads soldered to this connector here. So that's an option for you if you would like to do that as well. I've also changed the switch from just a regular 4-post push button tactile switch to a lever switch, and I'll show you more of that in a minute, and I'll show you where you can get this part if you want to use it. And then lastly, I took one of the unused logic inverters that was sitting down here before, and I placed it up here. It's driven off of the output of this this one-shot, if you will, this timeout timer. And the plan is that actually I will populate only one of these LEDs, but it'll be a bicolor LED, meaning that there's an LED that points to the right in the package and then another LED that points to the left that's within the same package. And so I'll populate that, and the idea is that when power is present here at node 2, a green LED will go on and stay solid, and then when this goes low, the voltage across this diode will reverse, and the other diode that's in parallel, anti-parallel with it, being a red diode, will turn on, and that'll be a visual cue for the holder of the gun that their gun has ceased to fire. The LED dot laser dot is now off. So you could do this with 2 discrete LEDs, but my thought was eventually to put 1 bicolor LED here. Totally optional, you don't have to do that. Okay, so let me switch to a page, some just SketchUps that I've done for my particular gun. All right, so here are the CR2032 batteries. Here's the external battery holder that you have available to you. Here's the surface mount battery holder, which I've chosen to use on this design. And then this is the switch, the little switch that I've replaced, or that I'm planning to use a lever switch that I'm going to use as my trigger. And you can see here I plan on placing it something like this. It's quite a small switch. It's only 12.6, a half inch in length. Okay, half inch in length. So that's a pretty tiny switch. The laser diode is right here, and the plan there is that I'm going to stick it right here and make a slot and then hot glue it. Okay, so where did I get this gun outline? I went online and I just Googled for laser gun outline, and you get a bunch of them. Let's see, the one that I used somewhere down here. Did I pass it already? At any rate, you, I'm sure, can find some gun outlines. And I copied it, and then what I did is I used a program called GIMP2, which is a free program for Windows and for Linux. And I needed a grid, so I needed to pull off coordinates from the outline of the gun so that I could actually enter coordinates for my board outline. So you can make a board outline as simple as you want, but I wanted to give you an example of how you can make a more sophisticated one if you cared to. So I don't know why I can't find that one that I had before. Let's see if I grab this one. Okay, so this is open source, right? GNU GIMP2. So you can get that online if you want to. It may actually be installed on the lab computers. So we're going to paste the clipboard as a new image. So there I have that. And then what I did was maybe I cropped it. And then I added view grid, show grid, something like that. And then you can adjust the grid somewhere in here. There's a grid size. So I don't want to take the time now for it. But anyway, that's what I did. And what I ended up with then was I pasted that into, I'm using Microsoft Journal here because I've got a tablet laptop. So I pasted it in on this grid, and I decided that I was going to use 0.1 inch grid, and I just drew off or wrote off the coordinates at key points here. Right? So at the beginning and ending of an arc, I recorded those. I went around the whole thing, and once I have that, what I did was I opened up a board file. Okay, so if you don't have a board file created yet, you would see that here that you'd have no board, but I already have a board file. But if you didn't, when you clicked to open or generate or switch to the board, it would ask you about creating one. All right, and so typically when you open up the board file for the first time, it'll show you all the parts off to the side and give you a basic board outline. So I've put a couple notes here in terms of what I want to accomplish. Probably won't do it all in this video, but this is the overall plan here. Okay, so in a moment here I'm going to create some folder structure under my design where I keep my Eagle files, just to put things in a tidy, organize things in a tidy way. I will create a bill of materials from the schematic if I haven't done so already, and then I'm going to create this board outline, and that's where this these coordinates for the gun shape that you want to use will come in handy. We'll then place the components on the board. We'll make any adjustments to the wiring in the schematic based on the easing the layout. So for instance, if you notice that this potentiometer has 3 terminals, right? It wouldn't really matter if I connected this center post over here or over to the other side, or if I flip this entire resistor around. But based on how I wire it, based on the layout, it may actually make things easier for me. Similarly, there's no reason why I have to connect the gate to this terminal here on the switch as opposed to this one. If I wired it over here, then I'd want to change these labels, because now laser gun would be the case down here and laser pointer would be up there. But so there's sometimes an opportunity to make small changes to a schematic once you get into layout, when you realize that, hey, I sure wish I would have wired this switch the other way. It would make the layout easier. So we'll take a look at that. Then we'll route the board. We'll add ground fills as needed or as desired. We'll run design rules checks throughout. We'll generate some PDF views so that you can easily view your board schematic and different views of your board without having to open Eagle. That's something you'll thank yourself for later when you get ready to build it and you want to just print out like component placement and the schematic, etc. We'll run the CAM processor to generate Gerber files. We'll submit zipped Gerber files to freedfm.com, which is provided by Advanced Circuits, a board house that we use a lot, and it does a free design check, and it produces this really nice multi-layered single PDF that actually shows all of the layers, all your Gerber layers in one PDF, and you can turn them on and off. And so that'll be the process that we go over. So let's open up my file space here where I'm going to save my design. So I'm under Tools, Eagle, My Project. I guess I should show this in case some may not be familiar with this. I have a folder called Tools where I have subfolders that relate to different applications I use, Eagle being the one in this tutorial of relevance. And inside Eagle I have a number of folders from My Project where I actually put all my projects, to My Lib where I place any of my custom libraries, to in my custom CAM processors, scripts, user language programs, design rules, etc. So we'll go into the My Projects, which by the way I should mention, if you want any of the libraries that I am running, you can look at this site right here. It's a Google site, and there's I just started it or just created it, so there's not much there, but I've placed all of the Eagle files that I'm using in this design, including all of the libraries. So those of you who already are familiar with this and are wondering about that one switch that I've shown here, this guy, which is this switch right here, I've added that to a library, and it is, I now have a JPG 16v2, which is an update to the 16v1, so you can grab that if you care to. Okay, so let's go back to the directory structure here. I'm going to go into My Projects and then find where I'm working this. And here I am in the folder where I'm putting all my CAD files for this project. So this is called Laser TX, and in here at the top level I'm going to have a number of well, I'll have at least one schematic and one board file. In my case I have several because I have kind of taken snapshots of the design along the way. So right now I'm using the file called No Outline because I haven't created an outline yet. But at the very least you'd have schematic and board at this level. And if this is a project folder, then you will have an Eagle EPF, Eagle project file that will reside here, and that gets updated automatically. And then you will create a PDF folder where any PDF output will be located. So for instance, when you're all done, you should be able to generate a PDF that shows all the top components, top place components, which will be very useful when you go to build the board. Create a bill of material folder, and here you can create your bill of material from your schematic. If you have the custom libraries, menuing I should say, that I have made available, and by the way, that's available also on here under my SCR right here. If you unzip this latest one here, then you can have access to all these menus. So I have it under Utility, Generate BOM. I want to create a bill of material by value. I'll make an HTML and I'll save it. And I want to place it in the bill of material. Okay. Close that. So now I have this one I just created. So it's just a simple bill of material, but it's good to have that. Then create a CAM folder. You'll want a CAM folder for when we generate the Gerber files. Initially that will be empty. Doc is just useful for any other information. If you want to put data sheets, if you want to have a README, anything else, that's good to put things in there. Build has to do with any details on the actual construction. I don't know if I have things in there. Yes, I guess this is from, these are notes that I provided you, for those of you who have already started on the schematic. Okay, so now we have our file structure. Close that. Next thing we want to do is look at the board outline, since we've created the bill of material here. So one way or another, what you want to do is to create an outline, and I would strongly recommend that you actually sketch something out and you put coordinates. If you have coordinates, this goes really quickly, as you will see from my demonstration here. Okay, so you can, first thing we're going to do is I'm going to turn off all the layers with the exception of the dimension layer. The dimension layer, layer 20, is the layer that contains the board outline. That's the only thing that should be on that layer. I don't really want this outline, so I'm going to delete it. And now I have nothing showing. And we're going to go to the wire tool. All right, so I mentioned before, when you're drawing a schematic, you don't use the wire, you use the net tool. Well, here we are drawing a physical outline of a board. We're going to use the wire tool. Click the wire tool, and I guess I was on layer top doc before, because that all showed up. So you want to make sure that you go up and select the dimension layer. I'm going to also turn off top doc. I don't want that. So now I'm ready to enter coordinates. I can enter coordinates, but instead of clicking, I'm going to type coordinates in. It's much faster. So you have to have clicked wire, or you have to have typed wire. And then up in the edit box here, I'm going to start entering coordinates. I'm going to begin in this corner, bottom left corner here, and I'm going to work my way clockwise. I won't do all of these, I'll just get started. Okay, so you do open parentheses 0.3 comma 0, not comma, I'm sorry, space 0. Then 0.2 space 0.3. Zoom in here. Let me undo this. Notice you have a choice of the type of lines you want to draw, the bin style. I need to have this bin style too. So I'm going to Control Z to undo this. Choose the bin style too, that's important. And let's start over again. 0.3 space 0, 0.2 space 0.3, 0.6 space 0.9, 0.6 space 1.3, 0.05 space 1.45. You get the idea here. We'll do a couple more. 0.1 space 2.15. 0.8 space 2.2. 0.85 space 2.45. 1.6 space 2.45. Okay, and now I'm going to show you, notice that this next line, which goes out here to 3.1, 2.3, is an arc. So perhaps it's useful at this point to actually select an arc, or the bin style 7 here. All right, and some of these I can correct later on, but I'll go ahead and put this one in directly. So 3.1 space 2.3, and I have this bend, and then let's go a little further here. We'll say 4.0, 2.1, and 4.3 space 2.0. All right. Now I don't want the bend anymore. I don't want this bend style because I need to take a sharp right turn. So we will go back to bend style 2, and I'll put 4.25 space 1.95. All right. Oops. I think I did that wrong. So if it gets interrupted, the key is that you have to have a closed shape. All right. You can't try to guess on this. The way you're going to grab this, especially if you've been entering coordinates, is you want to go back and enter coordinates. So we were at point 4.3, comma 2. Because if the shape is not fully closed, you will have errors you won't have a good board outline. And you'll have all kinds of errors that result from that. There we go. All right, and lastly, 4.4, 1.8. All right, had escape there. We'll stop. So we've got this much of it already. Now, back over here, I had a bend, right? It wasn't straight. So what I can do is I can come back, and fortunately in these cases, I do have a grid that is 0.05. And all these coordinates are pretty much in increments of 0.05. So if you do that, then you can actually just click without entering coordinates and you'll be spot on. So, but don't do that unless your grid size is actually the same increment as the smallest increment that you have in the coordinates that you are entering. So I'm going to get the bend here, and I'm going to click here. Oops. You can also right click, it'll go through it. Well, that's not what I wanted. Let's go here, snake. Why is that not bending? How did I do this? Oh, you can do, let's see, we could try arc. Let's try arc. No, that's no good. Try arc here. No, that's no good. How did I do this before? I had a wire. I'm sure I had. Oh, I know what I need to do. I need to delete this line. That will help. Let's go back and do pull this over a little bit so you can see what I'm doing. I just realized you couldn't see this off to the side. I'm going to go bin style 7. Oh, so you can just basically click here. You just do it in a couple clicks. That's what it is. And then I'm going to straighten this back out. There we go. All right. Sorry about that. So you can work on that. All right. So you'll end up getting your board outline this way. So I'm going to close this. I'm not going to save this because I have another board. Notice this warning comes up. Do not do any work on your schematic or board if you ever see this warning. If you do and you save the changes, your board and your schematic will be permanently out of sync, and it is very hard to get them back in sync, and you will most likely have to start your design entirely over again, or at least delete your board and just go back to your schematic and create a new board all over again. So now let's go to placed. Well, thought I had one that didn't have all the parts placed, but okay. All right, here we go. So here's the board outline, and I have some parts placed here. It's not my final placement. My final design is different. But what you're going to want to do is, actually what I'm going to do here, let me pause this, and because I'm going to create a board that has the outline but no placed parts, and then I'll start this video back up again. So I'll be back in just a second. Okay, so now I'm back. I've got the board outline and I have no components placed. They're just down off on the side here. So first off, usually when you go to a board layout, all the layers are turned on, typically, which is more than what you really need. So I'm using the custom menu that I have, so I just go display 2 layer, and that cleans up a lot of this. So it shows me the typical layers that are important for placing a 2-layer board. It doesn't show me all the solder masks and all that kind of stuff. So it is it's less cluttered. All right, now you can move parts one at a time, like go down here and say, okay, I'll move this guy here. Let's see where he goes. But what I prefer to do is I prefer to reference the schematic and actually type in the reference designator that I'm trying to move rather than going and hunting for it. So I kind of work through the schematic and place things as I see fit. So for instance, I start over here by the battery, and I have a BAT1 and BAT2. These are those surface mount battery holders, and I want to place them in this area. So I'm going to click the move command, or Control S, and then I can just type in BAT1, enter, and right there it puts the BAT1 in motion, and I can place it. Now I'll put BAT2, and I want it on the bottom, because the idea is I'm going to have actually the only thing I plan on putting on the bottom of my board is the second battery holder. Everything else is going to be on the top side. So if you press the middle mouse wheel while a part is floating and you're in a layout, it actually places it on the bottom board. So I'm actually going to place it exactly on top. They're now one on top of the other. And if I were to move one, notice that there's a connection because they're in series, right? They're in series, right? I can actually check this out. If I do show, I click here. Notice that when you click show, it highlights this net here and these pads. So that's the connection. So when I go to place this on top of this, there is a connection that needs to be made. And so we'll come back to that a little bit later. All right, JP1. I need to move JP1. JP1. I'll just put him here for now. Next, we've got switch S1. So type S1, and here's the switch. Now, this part that I made it in haste, so it doesn't have a great library or footprint for it. If you go to, let's go here. If I turn on the layer top document, so top doc and bottom doc are added information that you typically want when you're printing out a document. It's not going to go to the board house, but it gives more information. Now, why is it not showing that top? I'm confused now. Why is it not showing me? Hold on a second. Okay, I know what's going on now. All right, what happened is I originally drew this part, and I didn't have any kind of an outline for the switch. I used it in this design, and then I updated the part in the library. And when I did that, I never updated the part in this design. So basically, a design will actually cache all the parts that it uses from a library until such a time that you go up and you ask for updating a particular library or all of them. So now when I click update all, it's going to go pull the most recent or most updated part information from each library from which a part in this design comes from. and now you see that this outline comes in. Now I have a problem here. I want my switch to be at this angle, but when I right click on my mouse I only can rotate it by 90 degrees. So what I need to do is I want to have it at an angle that's the same as this line here. So if you click on information and click on this line, we see that the angle is 63.44 degrees. So I want to do the same thing here, 63.44. So if I put in an angle of 63.44, now I have the switch in the right orientation. I don't recall if I want it pointing up or down. No, this is the right way. I don't have a choice really. So now notice that I can't quite position this as I want, and my grid is actually 0.05. But recall that there's an alternate grid that you can use, which you get by either typing grid or clicking this icon. The alternate grid right now is 5/1000ths of an inch, and you get to that by holding the Alt key. So I'm going to hold the Alt key now, and now I can place this. There we go. Alright, so I think I've shown you the main things I want to show you in placing parts. Don't go fishing for them. Instead, look at your schematic and make sure you have the move selected in your board, and just type in the reference designators so you can pull the part. You don't have to go looking for the part, and place it wherever you want it. Okay, here I'm showing you what the board looks like after I've put an initial component placement, or completed initial component placement. And actually you see that initially my goal was to place all the parts on one side of the board. I was actually hoping that I could place all the parts I was hoping that I could not only place all the parts on the top, but I could also do all the routing on the bottom, such that I would have basically a one-layer board. That was not really possible. Once I looked at this a little more, things were getting a little tight, and I thought, I'm going to have to route on both sides anyway. It's going to have to be a two-layer board, so I might as well put this extra battery down on the back side and kind of free up a little more space over here for the layout. The board outline that I have here also was one where I had not made the cutout for this switch yet, so I had made an adjustment to that since. Now you might wonder, how do you know how to place parts? Your guide is really your schematic. Sometimes this works really well when you're doing discrete parts. When it doesn't work so well is when you have an integrated circuit that has multiple gates. For instance, in this case, the IC, the Schmidt trigger inverter, where all of these gates now are all kind of centered around this one IC, so you can't spread these things out very well. So it's kind of just a trial and error to do this a lot of times. I would say, for the discretes, I definitely start off and I say, I look at how the circuit flows, and I lay things out accordingly. So I know that after the batteries, I go through this switch, which actually I have to have it here because of the way I plan on accessing the switch. Then I have diode D1, which I've placed here, and I can move that around in various positions here. Then from there, I know I'm going to this resistor divider R1 and R3, which I see right here. I have a capacitor C1 right here. When I get to the IC, because this C2 is tied between the rail, the power rail, and ground, I know this is a bypass capacitor that is needed to basically provide clean voltage to the IC. So you usually want to put a bypass capacitor close to the IC. So I've placed my C2 right here. It's pretty close to it. This part of the circuit here where I have the C3 at pin 3, I have placed here, not super close. I might want to switch these around, right? But you start kind of getting an eye for, well, this is where it's going to have to route. I got to route all these little air wires, which incidentally, when you are placing things, what you want to do is run the rat's nest pretty frequently. So you can do that by clicking on rat's nest, or if you are using the shortcuts with my custom script, you can just do Control A and it runs the rat's nest. And that will always update the shortest path between any two connections that share the same net. So if I move C3 back up here and I do rat's nest, you'll see things get rewired, vice versa. I wanted my switch for the modes down here, so I went ahead and placed that, and I'm going to try to work with that and see if I can get things to route well. I know that the laser at the output needs to be here. So our package is an LED, but I'm not actually going to place the LED. I'll place the laser here and then wire the leads here. And I might even want to move this back a little bit just to be a little further away. And I'll hot glue the laser into this slot here. The R2 and the transistor are all sitting right here in pretty close proximity. The RC oscillator here, which has C3, R4, and R5, and connected between pin 3 and 4 of my IC, are wired right here. I've got pin 3, R4 goes to R5, then back, and then it's got to make it through here. So it's just trial and error. You're going to place it initially in the ballpark area, and you work with the layout, and then if it doesn't fit, at some point you decide to move things around. Now I want to show you an example of a case where I'm going to actually change wiring in the circuit. So you notice this this switch right here. I'm going to go ahead and route. So when you route, you're going to use the routing tool here, or Control R, and I'm going to route on the bottom. And I'll talk about this a little bit more later. And I also want to use a route width of 16 if I can, 16 or 24. So I'll go ahead and connect this. Those are connected. Now I have this dilemma that I need to get this guy over there, and I could go down here and run him along here, but that gets pretty close. And I'm gonna have a problem running out of board space. Right there I'm on the edge of the board. I have to bring him all the way around here. So instead, what I'm going to do, I'm going to rip up this right here, and I'm going to go back to my schematic and look at what I have going on here. I'm using pins 2 and 1 and leaving pin 3 not used. There's no reason why I couldn't just rewire this to connect down to here. All right. Now my switch is going to be, I have to change my labels, but this works. All right, that works. So now look over, I'll save it, and notice now how the rat's nest goes. I will route, oops, route here, here, and then now I can route this. Whoops, that's probably close. And hold the Alt key down to get kind of wiggled through here. All right, now I have other problems. I have to get like this signal across here, but I just wanted to show you an example of where sometimes you can rewire something in the schematic once you're working in the layout and realizing that moving things around would be helpful. All right, in terms of routing, you want to route on the bottom side primarily if you're doing an LP, if this is going to be milled, if your board's going to be milled on a circuit mill rather than sent out to a board house. So this board that, at least if you're in my class, we'll be designing, the board you'll be designing is going to be milled in our own lab on our LPKF circuit board mill, which is a subtractive process. You start with a full board and then it just mills away copper. It can drill holes, but it can't plate holes. So the rule is that to make the soldering easiest, if you place the parts all on the top, then you want to make all the connections on the bottom because it's going to be on the bottom where you're going to be soldering. So you should try to route your board completely using blue traces in this case because the parts are on the top. Now I have an exception here that in my final design, one of these battery holders is actually down on the bottom. And but we actually treat surface mount parts a little bit differently. Here you only have 2 of them to contend with, so it doesn't matter. You can just, if you choose to use a surface mount battery holders, you can put them on the same side, either side, or one on the top and one on the bottom. All right, let's let me show you 1 or 2 things more. Let's say that I had I don't know. Okay, let's say I wanted to route, make this connection here, but I didn't want to go from here. Now, in this case, I could start here and I could go down. Say I wanted to end it here. That would be fine. But let's say, actually, let me do that and let me show you how. I'll go ahead and connect this and say I don't like how that's connected. If I go to route again, I'm clicking and it will not let me route anymore here because there's nothing left to route. So I either have to rip this trace up, which you have to be careful because if you double click this, it'll rip up the entire net, which you don't want to do. Or if I don't want to rip up, I want to show you this one little trick. You can hold the control key down while so I'm holding the control key, and now I can click anywhere on a current trace and it begins a new trace, even though there's nothing left to route. So now I could connect this here. Oops, no, let me try that again. I can let go of the control key now once it started and terminate it. Now I can go back and I can rip up what I don't want. Now this is actually a bad layout. You don't want to route it like that, but it goes to show, I wanted to show you how you could actually start a new route when there's no air wires there to get you started. You can hold the control key. Okay, I see that this video is going long, and I still have quite a few things to show you. So I'm going to split this up into another video, which I'll have to post later. But what I want to do lastly before quitting is to pull up a help page that if you're in the class, you will recognize this as being on the course Evernote page. And I want to just go through some design rules. These are specifically, or most of them are applicable to when you're doing the in-house, when the board is going to be fabricated in-house using the LPKF PC board mill. So some of these guidelines are specific to milling using our circuit board mill, but and I'll try to point that out here. All right, when you are going to route, you want to use the routing tool, which is this guy down here. When you want to rip up a route, you don't delete. Okay, you don't delete a route like you would delete a net in the schematic. You rip the net, you rip the route up, and this is the rip up tool. So if you're using my shortcuts, it's Control R for route, Alt R for rip up. You want to make sure that you're going to be routing on the proper layer. So you should either be routing on the top or the bottom. Usually you're going to be routing on the bottom because your components, I'm assuming, are going to be placed on the top. You get to choose the width of the copper traces that you lay down. So whenever you go into a routing mode, you will see a menu up at the top and you get to choose the width. Try to use a 24 thousandths of an inch width. That's pretty beefy. Most standard PCB board houses can easily do 7 or 6 thousandths width, but with the PCB mill, which can go down to like 10 mil, it's just easier and more reliable if you stick to something big. So try to do 24, and if you can't, you can go down to as small as 12 thousandths, but only do that where you really need to. Like I had mentioned before, you want to route on the layer opposite to your components. So I'm not going to read through all of this, but the basic idea is that if I route, as you see in this example here, let me zoom this up. If you are routing, so I have these three red top traces that I've routed, and the parts are placed on the top. In order to make electrical connection, I have to place solder on the top pad here. It's not sufficient to put solder on the bottom because these holes are not going to be plated like they normally would be if this was coming from a board house. On our PCB board mill, all that happens is you start with a two-sided solid copper panel. So I mean, it's a FR4 board with solid copper on the top and the bottom, and the mill will route copper or mill copper off on the top and bottom and drill holes, but those holes are not plated, so there's no electrical connection between the top and the bottom. So in order to make a connection between top and bottom, if that's what you need to do, you have to apply solder on the top and on the bottom. In this case, we're simply trying to make a connection to the top. So you'd have to solder to the top here, which is possible when you put an IC in here. But let's say you have an IC socket. That socket, which is a plastic housing, will cover this pad and you won't be able to get solder to it. However, parts that are prone, like these resistors and diodes, here you can easily access the solder or the joint on the top, and you can apply solder to the top. So in some cases it's okay. For instance, the connection going between D3 and D2 here, you could route that on the top because you could add solder on the top of this connection and this one here. The key, though, is that you remember when you build your board to apply solder on the top here and not just on the bottom. Otherwise you won't have an electrical connection. If you do have to route on the top because there's some other trace that has to cross it, and you need to use the bottom layer to do that. So in this case here, I need to get this blue trace out and to the right. I obviously can't place that on the top, or conversely, I can't place this route on the bottom. Otherwise, it would connect to this route that's going east to west. So in this case, I can route on the top. But what I should do is I should place what's called a via. A via is basically going to, usually, it's a plated hole that makes an electrical connection between a top trace and a bottom trace. Doing this allows me to only have to solder this pin of the IC on the bottom because my trace is connecting on the bottom. However, here in this via, because I don't have plated through holes using my circuit board mill, I'm going to have to stick a small wire through it, or you will if you do this, and then add solder on the top and bottom of this solder pad in order to make the electrical connection. And the key is you want to place vias in locations on your board where you can access them with the soldering iron. So here I could certainly do this. It might be best to solder this via in before I place this IC, just to give myself a little bit more room. Once you've laid out your board, you also want to make use of ground planes, and so you use the polygon tool to do that. And you want to set the width as a guide, not always, but you want to set the guide as a guide. You want to set the width of the polygon to 12 thousandths of an inch, and there's a parameter called isolate. You want to set that to 24 thousandths of an inch as a starting point. You draw your polygon around the board. It does not have to, and you want to draw one on the top and the bottom if you're going to do a ground fill on the top and bottom, which you should do. The polygon does not have to hug the board outline. In this case, you see that I've just made, kind of coarse outlines or rectangles surrounding my board. And once you execute the rat's nest, it will fill in any polygons that you have actually drawn. But before that actually happens, or before it happens correctly, meaning that the fill only will occur within the outline of your board, you will need to name your polygons. So those polygons actually become copper, and that copper needs to be associated with a trace, with a net. So typically you want it associated with a net. In our case, we want it associated with ground. So you want to use the name tool and pick each polygon and give it the name ground. And once you do that and you run the rat's nest, you should see the fill should only occur within the outline of the board, provided that you have a closed outline. So to show the ground plane, click the rat's nest button. The ground plane will fill the polygon up to the edges of the board. To hide the ground plane, you can use the rip up tool on the original polygon you drew. If you can't see the polygon, you can also type rip up and then the @ symbol. Incidentally, I've updated my custom menu so that now I actually have a I have a tear up. So let's see. I have rip up polygons. I have, and so if you want to get that newest one, you can go to the website I pointed to earlier and grab my latest script zip file here to get that latest version. Okay, you will also see a parameter called, or a checkbox called orphans. This is in the property dialog for a polygon, and you want to select this. Okay, so it's preferable to check this when you're milling with the LPKF mill, and I'll explain here what it does. I'm not going to explain it here because I'm really running out of time. Lastly, you can judiciously add vias to help connect isolated ground or power planes across the board. So in your case, you probably will just have ground planes, ground on the top and the bottom. So what I'm showing here is I have these two orange, these are unrouted, these are rat's nests that I've highlighted. And if you notice, this pin of C3 is actually tied to ground, the ground plane here. This pin of the IC is tied to the ground plane right here. And this pin of this transistor is tied to this ground plane. Unfortunately, these three ground planes have gotten isolated from each other. That's what the orphan checkbox does. It allows it to fill areas that it can't be connected even though you want them to be electrically connected. So it's telling me that these are not connected. Now I could actually solder, if I could put solder, so what I need to do, or what I can do, is I could provide a ground fill on the top. And that ground fill on the top can actually help connect these three grounded areas. Specifically, those connections can happen through this pin, and this pin, or this one. But again, I have the problem that I need to solder to the top and bottom of these solder pads, which is difficult to do for these parts. So an alternative is to place some vias, which I've done here and shown in these boxes. I've placed the via in this ground plane, one in this ground plane, one in this ground plane. And now I'm going to place a top fill, a top ground plane on the top of the board. And if I put in via wires here and solder at the top and the bottom sides of those vias, I will be effectively connecting this ground plane, and this ground plane, which are right now isolated from one another because of the other traces on the bottom of the board. They'll get connected through the top ground fill. And so that's something that you can keep in mind or look for in your design. All right, I think I've gone through all of those important rules, and let's just lastly return to the list that I had. Where was it? I apologize. Okay, I realized that I actually didn't save that file, so I don't have the list of things that we were going to go through. But I think you have right now enough to be able to, one, create a board outline, place your parts, and then largely route your board, add some polygon fills and connect them to ground. And then what you'll need to do is you need to run the design rules check along the way. And you want to make sure that when you run the design rules check that you are running the one that was provided to you from Mr. Bosson. And that one is called right here, LPKF HS hand solder 1VO W Bosson. All right, so make sure that you have that one loaded when you run your check. And lastly, notice I have lots and lots of errors here related to stop mask. What you want to do is you really want to just view the two layers, or you want to display two layers. You don't want all of these additional, like top cream, bottom cream, top finish, top glue, all of this. You just want the basic, these top up through 26 essentially. Those are the only layers you want showing. So now when I run the DRC, I get fewer errors. I still have some errors, and actually in my case I'm going to ignore them. These are dimension errors where it's telling me that I have some copper too close to the board. However, I happen to know that with our milling machine, copper can get up very close to the edge, and that won't be a problem, so I'm going to leave those errors. Okay, so this was rushed, not well rehearsed, but hopefully it gives you some good basis for being able to do your board layout. And yeah, I would encourage you to find a creative gun outline, or again, if you want to keep it simple, that's okay. But what you should do before you make a board is you should think through how you're going to package this as a final gun. I expect that this will look like a gun in the end. It won't just be a blank PC board. So you can make a really simple rectangular PC board, but then maybe house it in something that's a little more shaped like a gun, using anything from cardboard to wood or anything else. As I mentioned, we can 3D print or laser cut, specifically laser cut some materials if you like. But you want to think about how you want to mount your circuit board in there. So maybe in your case you want to put some holes in your circuit board. You'll want to think about, should I use the circuit board to hold the switch that I'm going to be pushing, or whatever the case may be. But you should think through kind of a design of the overall gun before you commit to a board outline and a component placement and then a routing. So I'm going to need to follow this up with basically running the Gerber files, basically creating Gerber files by running the CAM processor, and then submitting that to the free DFM online. And I think at that point, and then generating the different PDF views. So I'll make a video, plan on making a video to just show you that, but that should be much shorter than this first one. So, all right, hopefully this will be helpful to you, and that's all for now.